So our next session is going to be an update on the Stealthwatch portfolio. We have Carrie Armistead, who's the Director of Product Management, to give the update. We have a number of question managers again, so please put all your questions into the Q&A panel in WebEx. Thanks, Carrie.
Great, thanks, Bill. Thanks, everybody, for coming. I look forward to telling you a little bit about Stealthwatch, where we are, where we're going. Certainly got some great people helping answer questions. If there's time, you can ask me questions. But again, thanks for coming. Just in a way of additional introduction, again, my name's Carrie Armistead. I have been with Cisco for about 2.5 years. I was brought in as the acquisition of Landcope, so I was Vice President of Product Management for Landcope prior to getting acquired by Cisco, so I've been around Stealthwatch for about 5.5 years now, so fairly knowledgeable on it. Real quick, just wanted to level set the stage. I don't know how many of you are familiar with Stealthwatch. Who's heard of at least Stealthwatch? That's a fantastic number of hands. Great. So just the level set Stealthwatch, because I know with some other products coming in like Tetration, there's been some confusion about what is Stealthwatch, how does it fit into the security landscape. At the end of the day, Stealthwatch is intent-based behavioral threat detection. So what we're looking at is we're trying to find the malicious activity that got past the other security controls. So you could call that insider threat because anything that got past your traditional security controls is now on the inside of your network. But also looking at, as the network is evolving, how do we help protect the seams that are going outside the perimeter now. So some things that you may hear associated with Stealthwatch: encrypted threat analytics. How many of you have heard of encrypted threat analytics? Not quite as many people, but still a good number of the room. So Stealthwatch is absolutely needed for ETA, encrypted threat analytics, to work. I'll walk through a use case around that a little bit later. But you'll hear, when you hear ETA, think of Stealthwatch. Breach detection, so again, things that have gotten past traditional security controls. We have public cloud threat detection with an acquisition we made last year, allowing us to really look at public cloud infrastructure as a service workloads and find threats going towards that. Automated threat modeling, behavioral threat analytics, and yes, we actually use machine learning, contrary to what a lot of people will say, and we'll talk a little bit about machine learning, how it plays a role in the Stealthwatch. One of the other things I want to talk about is a lot of people look at Stealthwatch and say, hey, it's a great NetFlow tool. And that is absolutely true. We are awesome at analyzing NetFlow. But we take in a lot of different types of data sets. We take in user data from ICE. We actually get it from proxy, so we take proxy data in. We take application data in, next generation firewall data. So we actually have a very broad set of data that we take into our security analytics to provide, one, high fidelity analytics, and then two, the context when the customer is actually trying to do an investigation on what was actually affected. We have that contextual information to have the quick triage component of it. We run this all through our statistical machine learning and the semantic reasoning analytics to provide outcomes around the things that we talked about on the previous slide. So what I thought I would do is just talk about some real use cases real life world cases that Stealthwatch has benefited our customers with. So in particular, this one, detecting a rogue server. What we're able to do here was we had a customer, a media company that was looking at acquiring another media company. They were a Stealthwatch user to begin with, and what they were able to do is take the Stealthwatch instance they had, apply it onto the potential acquired company's network, and very quickly they found a rogue server that the company didn't know about that was actually communicating externally and then also trying to attempt to connect to other segments inside the network. Because we have 100% visibility of the network, we're able to see the communications inside and outside, and we're able to detect this rogue server. So think about it. For the company that was being acquired, we found a potentially malicious actor very quickly for them, and for the acquiring company, we kept that from getting onto their network and potentially causing havoc there. And then data exfiltration, again, because we see the entire network, we're able to see data moving both inside the network. We have several alarms around suspected data hoarding, so getting the data staged to leave, and then obviously we can see it leave. In this particular example, with the healthcare environment, right in the POC, the customer put Stealthwatch in. They were able to see internal users logging in from Singapore and China. Well, they didn't have any operations in Singapore or China, and nobody was traveling, so that was kind of an odd thing for them, and then saw information go into Dropbox. So again, because we have that internal visibility and see things moving and then that communications out, we're able to pick this up. And there's a lot of other examples just around these types of things. As a matter of fact, I remember visiting a healthcare organization in New England, and they'd had a nurse take a laptop home. Their kid got on it, surfed the internet, played some games, whatever. She plugged it back in, and all of a sudden they saw a beacon go out to Ukraine, and the beacon go out to Paris after that, and we're able to track the movement of the malware through the hospital, pinpointing the 10 servers that were the only ones that were actually susceptible to it, and we're able to clean it up pretty quickly. So those are the types of things that Stealthwatch provides for a customer. And this is using really more of our statistical engine. So we have 100 security analytics that are using statistical algorithms. So we'll take in the various types of telemetry that we have, put it through that detection engine, and then we have the anomaly detection off of that. So that's one part of what we provide. So again, Stealthwatch equals ETA. It's surprising to me how many times when we talk to some sellers, they understand they got to sell the Cat9K or the ISR or the ASR. They're not sure, they forget that the Stealthwatch component is actually really important because we're doing the threat modeling on the ETA. I won't spend a whole lot of time on this slide, but as we all know, networks are becoming more and more opaque. More encryption is happening on the networks, and if you look at Gartner, they're expecting that to climb to 80–90% over the next several years. And then we've seen with our own research at Cisco, more and more malicious activity is being embedded into encrypted traffic. So now that makes it really hard for a lot of security tools to understand that there is malicious activity happening. And that's why ETA is just a phenomenal solution. So what is ETA? We have two things that we do with ETA. The first one that most people are aware of is detecting malicious traffic in encrypted traffic without decrypting. So we don't have to decrypt anything, no heavy compute to break the encryption. We understand that this is encrypted traffic and are able and can find malware in it. Matter of fact, there's a Miracom report that is either out or about to come out where we actually had them test the efficacy of our encrypted traffic analytics. We were able to find 100% of the encrypted malware that they were using in about 3 hours. So it's pretty quick turnaround on that. So good efficacy on it. The other thing that we were able to do with encrypted traffic analytics was have cryptographic compliance. So a lot of organizations have policies where they say X percentage of the network needs to be encrypted, we need to be at this encryption level, so now TLS 1.3, maybe TLS 1.2 before that. But do they have a way to actually measure and say, yeah, we are in compliance with our own policy? The short answer is not until today. With ETA, as we look at the encrypted traffic, we can tell what encryption level they're at, and obviously what percentage of the network is actually covered with that encryption, and can pinpoint, hey, here's a server that is a lower encryption level, go do something about it. So let's put this in action. How many people are familiar with Mobile World Congress? All right, not as many hands that time. Mobile World Congress is an absolutely huge show. About 120,000 people, 107,000 people went to it. When you look at it, 7,700 CEOs walking around the show floor of Mobile World Congress. Now, all of us that go to trade shows would love for a CEO to walk into our booth and have a conversation, convince them to buy our stuff, right? Well, in this case, they actually are doing that. But it also means we've got some high-profile people walking around Mobile World Congress. Just to give you an idea of the encryption levels at Mobile World Congress, all those predictions are coming true. 82% of the traffic at Mobile World Congress was encrypted. We did a similar thing with Stealthwatch hooked up at Cisco Live in February as well, and I think the encryption levels were 80%. So we are seeing a lot more encryption happening in the wild today. So what were we able to do with it? So Stealthwatch was running, all the Mobile World Congress was going through the Cat 9Ks into Stealthwatch. We were able to find 13,500 things that we thought were bad. Using our machine learning, we actually would take that from 13,500 things, which is an enormous amount of things to think about, to 350. Importantly, we saw crypto mining, Android Trojans. You can read the list. I don't have to read it for you, but this was stuff that was happening on the network that was encrypted. We saw communication going through PowerShell to command and control servers. So this was a live case where we had traffic running through 82% encrypted. We were able to find things in it. How does it work? Really, the magic is in the first two, and the third one adds a lot of good context around it. So the initial data packet. The initial data packet allows us to look right before a packet is routed, what is the application that's being used here. That's how we pick up what encryption level it's at. Next is a sequence of packet length, easy for me to say. So our data scientists you looked at sample after sample after sample of good benign network traffic, and we're able to pick out patterns. This is what it looks like to go surf Google. This is what it looks like to go to email. Then they put malicious traffic through it, and the patterns were broken. So we were able to pick out, because these do not actually conform to normal patterns for network traffic, these are typically malicious traffic. And again, we've had high efficacy rates with this. And then because we also have, with our global threat analytics platform, ability to see where malicious activity is actually coming from, we can correlate that as well for even higher efficacy. Talking a little bit about machine learning. So this is all backed by machine learning. This is also how we take the large number of alarms that we're seeing in Stealthwatch and bring them down to something that's consumable by the user. So we start off with anomaly detection, so relatively noisy. We go through trust modeling, event classification, all the way down to the bottom piece of it, which is where we say, hey, this is a relationship modeling and this is something bad. We'll actually raise the threat level as it goes through this, so we have indications of this could be bad as we're learning more about it. But once it gets down to a 9 or 10, it's something that a customer should go look at. So that's how we take the 13,500 to 350 things that the customer actually should go look at, and when they click it, they're happy that they did. And then specifically with ETA, what does the customer need to be successful with ETA? Initially, it was just the Cat 9K, but it's Cat 9K, ISRs, ASRs, and CSRs. So a pretty broad amount of the network infrastructure is currently creating the ETA fields. There are extensions to NetFlow, which we do very good at. And then you need Stealthwatch, our on-prem version of it, which will actually do the analytics piece of it. We have a cloud version we'll talk about in a minute that ETA will come into, but right now we need the on-prem version. Matt Robertson, who is somewhere over here, he loves beavers. We had a whole presentation with beaver hats and beaver suits and all kinds of stuff. He's going to do a presentation, an actual walkthrough of crypto mining in his session. So we'll go to the Stealthwatch deep dive. You may get a Canadian 5-cent piece with the beaver on it. I don't know, Matt, you giving those out this time? Okay. We're not giving out money, but he'll walk through the, I was trying. All right. All right, so what's coming out? Actually, this is labeled soon to be released. I can happily say this is released. It actually went GA today. So very excited about that. So what came out in Stealthwatch Enterprise 6.10.2? One of the things that we got feedback from a lot of SEs was it's relatively hard to do a proof of concept with Stealthwatch, not because it's necessarily hard to get it up and running from a technical perspective, but licensing is kind of hard. So we said, all right, well, what if we took, at least for POCs, licensing out of the equation? So we have virtual editions on KVM that have a 90-day license period built into them, so you don't have to go license them with our back-end system. You run POCs, play with the technology yourself, see the greatness of Stealthwatch. So made that a little bit simpler. One of the other things we did, so how many people have heard of Stealthwatch Cloud? Pretty good. All right. So Stealthwatch Cloud has two components. We'll talk about them in a minute, but one of them is the public cloud monitor, where we're able to monitor AWS and now Google traffic and do threat analytics on it. Well, we've tied that into Stealthwatch Enterprise as well. So you now have one console for both your public cloud as well as your on-prem threat monitoring. And the other things that are in 6.10, we spent a lot of time, we're making a move from Java client to Web UI client. We made some good forward progress on that as well, a lot around doing some of the more investigation components of Stealthwatch. Cisco Stealthwatch Cloud. So I'm glad a lot of people have heard of it. How many people knew that it does both public cloud monitoring as well as allows you to monitor private networks? All right, that's about right. Because when we actually did a survey of our field and we said, well, how many people know about private network monitoring? Like, I didn't know what that is. So we do, from a SaaS capability, obviously we monitor AWS, Google, but we also can do the private network. So we have a small little appliance that will come down on the network, takes the NetFlow and other types of telemetry, packages it up, sends it to our cloud, and allows us to do the analytics. So with a SaaS capability, you can monitor both cloud and on-prem using Stealthwatch Cloud. That's just a picture of it. So on-prem, cloud. For cloud, so this is the AWS world. What we take in is CloudTrail, CloudWatch, Inspector, IAM, Config, and Lambda. Put that through our analytics engine and find threat actors there. Google last week, it came out so soon I didn't get it on the slide. Google last week just launched their beta version of the similar type of flow data. We've been a partner with them throughout that, so we are able to take that in today as well. So we now can do the multi-cloud between Google and AWS. We're working with Azure, so hopefully that comes fairly soon as well. So then we'll have the three major public cloud infrastructure companies covered. And then Stealthwatch Cloud, from an enterprise perspective, again, takes a lot of the same telemetry data that Stealthwatch Enterprise does, and again, provides the analytics. So what do we do in Stealthwatch Cloud? Again, fairly similar to what we do on-prem. Take the data, we send it out to the cloud. We have what we call dynamic entity modeling. So this is going to look at all the telemetry sources, user, NetFlow, cloud data, and says, okay, what is the actual content doing? What is that entity doing? Who does it normally talk to? What role does it play? How does it typically communicate? And using the machine learning in Stealthwatch Cloud, we're able to detect malicious activity. So very similar to what we do on-prem. One thing that's awesome about Stealthwatch Cloud, I love cloud technologies, we get good feedback on each and every alarm. So every time an alarm fires, you go and click on it, you look at it and say, hey, was this useful or not? The customer can say, yes, it was useful, no, it was not useful. 96% of the time, when the customer clicks on it, they mark it as this was highly helpful. But 96% of the time. This is not a third party that's paying Gartner or some other third party to do it. This is the customer. So these are highly effective, highly useful alarms. And there's not a whole lot of them. There's maybe 5 to 10, typically what a customer will see on a day. Again, because it's cloud-based, we're responsible for taking care of the infrastructure. So we do the patch updates. If something goes wrong, obviously we see it very quickly. We take care of that. We're responsible for what typically the security engineer or architect would do on-prem, and the customer can focus on the outcomes that the customers they're getting out of it. Other things that we've done, so Stealthwatch Cloud just recently integrated with Cisco Umbrella and Cisco Talus, so we have good integrations there, and we'll continue integrations around that. And those of you who have MSSP customers, we also have, this is also a great MSSP tool. We just recently finished our service provider license agreement with Cisco, so now we can use a SPLOC to price it correctly for an MSSP. This is also natively multi-tenancy, which is good for an MSSP. Has obviously the ability for the end customer to just see their data, but then we have an administrative screen that can be used by the MSSP, and then obviously all of this has APIs behind it, So a lot of MSSPs don't want to look at my UI, they want to look at their UI. Fine, just integrate it into your OSS. So good capability there. So what's next? So for the next 40 minutes, I'm going to go line by line. No, just kidding. A lot of things that we're working on with Stealthwatch. A lot of integrations, obviously the web UI becoming finishing up that. But a lot of this is also looking at how do we increase our analytics, largely by using the Stealthwatch cloud infrastructure. So we'll start integrating more types of telemetry, go through that entity modeling, and provide more visibility and findings. Some things that we're working on with Stealthwatch Enterprise, the on-prem version of it, certainly is trying to just simplify the customer's ability to understand what's happening on the network, what's wrong. So we're bringing security events and flows up in the web UI. So right now, it's another pivot down into the flow tables or into the event logs to understand what those are. For the ones that are important, we're bringing it up into our host report. So again, for customers, sees a list of these are the bad things, clicks on it, gets to the host report, and now they understand certainly the contextual information. And one of the important pieces, these are the alarms that are actually firing with why they're important to you as an organization. DNA Center, how many people are familiar with DNA Center? Great. So we're integrating with DNA Center. Two key areas here. First off, while NetFlow is not hard to actually configure, sometimes people have a hard time finding the right person to configure it. Maybe they can tell the network administrator to do it, maybe they can't. We're just making that easier. So from DNA Center, we'll be able to auto-configure from the router switches that the customer wants to send NetFlow to Stealthwatch. That can be done from DNA Center. That will also include ETA. And then we're going to feed back into DNA Center the security events that we're finding that are relevant to the network. So I have a good cross-pollination between what Stealthwatch is finding and DNA Center as well. This is just really the only thing on this slide that really matters, because that's the verbal description of it, is this is scheduled to go GA in July. One of the other things that will help our customers is really what we call auto-host classification. It could be auto-entity classification. But when a customer buys or even you're demoing Stealthwatch, one of the most important things that you can do is set up your host groups, because the host groups are the thing that we're going to provide the policies off of, and then obviously the alarms come off of that. Right now it's a fairly manual process. Either the customer has to go to their IPAM, they kind of figure out what they think it is. We have services arrangements to get this done, but we're trying to say let's automate that. So we're using our machine learning back end to find the hosts, group them, let the customer, because the customer says, look, at the end of the day, I love the fact you're automating this for me, but I kind of want to have my eyes on it before I approve it. So I approve it. Once we understand what they're approving, we feed that back into machine learning to provide better findings, and then continue that dynamic way of building host groups. This is the same thing on the other slide, just said differently. And then this is actual clustering that we found in some of our with one customer in particular, a medical healthcare organization in the Northeast, where they had pretty good host groups already. And we said, all right, well, we want to see how well we do with this matching what you had. So let's prove the efficacy of what we're doing. As you can see, we were able to group things very well. And when we compared it to what they had discovered, we had a 96% overlap between what they found and what we found. But we did it all automated. They had to do it manually. So this is a really quick way of finding the hosts and grouping them. Plus, I don't know if you all are aware of this, networks are relatively dynamic. Nobody calls the security guy up and says, you know what, we just added a few new hosts to the network. We're also talking to Azure now, so we kind of have to discover that on our own as security professionals. Well, this will pick it up. Say, this is something that I didn't know existed before. If it ends up being a rogue server, then you'll know that, hey, there's something new as a rogue server. Or you say, look, great, now it's classified correctly, and it keeps the system tuned very well. The other thing we've been very active on is adding detection types into Stealthwatch. We do this with 3 engines. We do the on-prem engine, we have the Stealthwatch Cloud engine, and then we also tie in with what's called Global Threat Analytics. It used to be Cognitive Threat Analytics. We get findings from that engine, which is great because we're finding stuff that is unique to the customer's network. The issue is it creates what we call the man with 2 watches, or in this case 3 watches. If he looks at his watch, what time is it? Don't know. So the same IP, for example, may have findings from all 3 engines. Well, which one do I believe? So we're starting to work on consolidating the outcome of those. So we have one prioritized list that the customer can look at and say, okay, now I understand that this particular host is in trouble. Let me go check it out. It'll also accelerate triage because you don't have to look at one thing, and then we'll pull back the relevant information around those alarms so the customer can make a quick decision. And then reduce the time of tuning because with our AHC, and then now we only have one set of alarms that's very focused, the customer doesn't have to tune as much. So this is a screenshot, or at least a mock of what's going to come up, where you can see we'll have one list of the alarms per host, the active events, and any other relevant information the customer needs to triage with. And this is my absolute favorite subject. I actually live and breathe this. So tetration. How many people have heard of tetration? How many people are confused about how Stealthwatch and tetration play with each other? There's more hands than that. Come on now. I hope so, because I spent a lot of time thinking about this. The reality of it is they're very different tools with very different outcomes that can provide great synergies together. So I'll start with the Stealthwatch side. What does Stealthwatch do? We're intent-based behavioral threat detection. We find the things that have beat other technologies, right? So we use behavior telemetry that comes in. Oh, did it? I am back. Thank you. All right. Do I need to start at the beginning of the slide? I enjoy it that much. We're really looking at how do we help the SOC analyst out. That's what we're focused at. When you go into the competitive landscape, who are my competitors? We actually just did a survey on this. So fortunately, the same people that are there showed up in the survey. Otherwise, I would have been concerned. Darktrace shows up. Vector Network shows up. Plixer shows up. I don't run into Illumio and other people in my market. So that's what we do. From a tetration standpoint, they're really, I like to call them ICE for the data center. They're policy and access for the data center. A little bit more sophisticated because they're a little more dynamic. They're getting down to a granular level that's fairly unique to them. But they're looking at understanding the workload and how to segment it. They also bring in a lot of different types of data. I think that's a lot of times where people get confused. They take in a lot of data. We take in a lot of data. But their outcome is really around that segmentation and enforcement component of it. They're going to go up against Illumio, NXS, so on and so forth. So very different outcomes for both products. The similarities, we both taken a lot of data. We both use some algorithms to do our jobs. When you think about what is the opportunity between Stealthwatch and a tetration, we're going to be able to see threats coming across the network or even in the data center that are going to, once we're tied in with tetration, they're tied into this is going towards that particular set of applications. Hey, tetration, can you do rapid threat containment on that? Can you block it? And they'll be able to do it. So there's a lot of great synergies between what we do and what they do. I won't go through this. We do have a roadmap with tetration we're going to start working on relatively soon so that we can get those integrations and start providing that value to our customers. And I believe this is actually my last slide, so I finished way early. A lot of time for open conversation. So Stealthwatch. Things I want to take away from today, it's intent-based behavioral threat detection. That's what we do. Sometimes people talk about segmentation with us. We can help there. It's not our core business. We're intent-based threat detection. And we can deliver it how the customer wants to consume it. So we went in the same survey to our customers. We were actually very surprised by the outcome. We said, how many of you are ready to do something like this in the cloud, meaning consume Stealthwatch threat behavior from a SaaS? 75% of the customers said they're ready to do it. So however the customer wants to consume it, if they want us to take the operational overhead from them and they want a SaaS delivered capability, we can do that for public and on-prem. And then we have an on-prem capability for those people that are not comfortable sending things to the cloud. Both scale up very well, both provide essentially the same value. And I think that is my last slide.